February 3, 1966. In a field outside Manchester, England, a room full of scientists has fallen completely silent. They are listening to a signal that was never meant for them. It is coming from the surface of the moon, from a place where, until this moment, nothing made by human hands had ever landed and lived. The man who runs the observatory is named Bernard Lovell. For days, he and his team have tracked a Soviet probe across 250,000 miles of space. And now, the instant it reaches the moon, the signal stops. They assume the worst, that it struck the surface too hard to survive. So they wait, and minutes later, the signal comes back, a long, rhythmic pattern they have never heard before. And then, they begin to understand what they are listening to. It is a photograph, the first ever taken from the surface of another world. And the men who sent it, in Moscow, have shown it to no one. Over billions of years, with no wind and no water, the moon's surface might have collected an enormous, deep layer of fine, loose dust, a grey ocean of powder, and anything that tried to land on it would simply sink, like quicksand, but on another world. This wasn't a fringe theory. The astronomer Thomas Gold argued that the dark plains of the moon were exactly this: vast dust bowls that would swallow a heavy spacecraft whole. The chemist Harold Urey thought the moon was a cold, primitive object, a frozen leftover from the birth of the solar system. Against them stood the geologists, who saw a moon shaped by ancient volcanoes and melted rock. And in the middle sat people like Eugene Shoemaker, the founder of planetary geology, who suspected the truth was a careful mixture of both. Here is the thing about that argument. Nobody could win it, because nobody had ever stood on the moon and looked. Every theory was built on a picture taken from far away. The only way to settle it was to put a machine down on the surface and have it survive long enough to send back what it saw. And in late January of 1966, the Soviet Union was about to try that for the 12th time. Now, the man who should have been standing in that control room was already gone. Sergei Korolev was the Soviet Union's chief designer, the secret architect of nearly everything they had ever launched. He had died only weeks before this mission flew. The first 11 attempts to land softly on the moon had all failed, one after another, and the project had been handed off to a different design bureau called Lavochkin, while Korolev's old team turned toward an even larger dream, putting a Soviet cosmonaut on the lunar surface before the Americans. Think about what that handoff really meant. The man who had built the Soviet space program from nothing would never see whether his moonlanders worked. He died with 11 failures behind the project and not a single success. And the new team at Lavochkin inherited that streak of failure, along with all the pressure that came with it. This would become the first deep space probe that bureau ever got right. But on launch day, none of them knew that yet. All they had was 11 losses and a 12th try. So this 12th attempt carried a lot of weight. 12 tries, a dead chief designer, a theory that the moon itself might eat the spacecraft alive. But the most important person in this story isn't in Moscow at all. He's in that quiet English control room, watching a strange signal scroll across a strip of paper. His name is Bernard Lovell, and he runs the observatory at a place called Jodrell Bank. And in a few hours, Lovell is going to make a guess that takes the Soviet Union's proudest secret and hands it to the entire world before Moscow can say a single word. Let's go back to that signal. The team at Jodrell Bank had been tracking the Soviet probe for days as it coasted toward the moon, listening in on its faint radio telemetry and quietly logging its position and its speed the whole way down. They were good at this. It was, in a sense, their job to watch what flew overhead, no matter whose flag was on it, and to write down where it was and how fast it was going. When the probe reached the moon, the signal had cut out hard. To the people listening, that sounded like an ending. Their honest assumption was that the spacecraft had simply hit the moon too hard to survive, that it was, like so many before it, a crash lander, gone the instant it arrived. They had tracked it faithfully all the way across space, only to hear it fall silent at the finish line. But then the transmissions returned, and they were different. This was no longer simple telemetry, the dry heartbeat of a machine reporting its status. This was something denser, structured, repeating in a way that felt almost deliberate. And this is the moment the whole story turns on. Lovell looked at that pattern and had a thought that, on the face of it, sounds absurd. What if this signal wasn't science data at all? What if it was a picture? Here's why that idea wasn't crazy. Back on Earth, newspapers had a way of sending photographs over radio. They used a standard system, an internationally agreed format that any newsroom in the world could send and receive. It turned an image into a stream of tones, line by line, the same way a fax machine works. And the signal scrolling across Lovell's paper looked, to him, like exactly that. Now sit with what that would mean. It would mean a Soviet spacecraft sitting on the surface of the moon was broadcasting its photographs in the one format that every newspaper on Earth could read. And it gets stranger, because later people would ask an obvious question. Why would the Soviets use an open international newspaper standard for their most secret achievement? Why not encode it? Why not lock it down? The British Broadcasting Corporation offered a quiet, remarkable theory. Maybe the engineers who built the probe chose that format on purpose. Maybe the people who designed this machine working inside one of the most secretive states on Earth deliberately fitted it with a transmitter that the rest of the world could read, so that no matter what their own government decided, the images would get out, so that the first photographs ever taken on the surface of another world could not be buried. We don't know if that's true. It's a hypothesis, not a fact. But it's the kind of hypothesis that changes how you see everything that follows. Because whether by accident or by quiet defiance, the door had been left open, and Bernard Lovell was about to walk through it. There was just one problem. To turn that signal into a picture, you needed a machine that could read it, a facsimile receiver, and Jodrell Bank didn't have one. It was a scientific observatory. It turned radio signals into line graphs on paper. It had never needed to print a photograph in its life. So Lovell did something that sounds more like a heist than an experiment. He called in the press. The local office of a London newspaper, the Daily Express, rushed one of their own fax machines out to the observatory in the countryside. And there, in a building never meant for it, Lovell and his staff fed the moon's signal into a newspaper's machine. Out came a picture, the first image of the surface of another world ever printed on Earth, but they had to guess. Nobody at Jodrell Bank knew the exact proportions the Soviets had used, how tall each line was supposed to be compared to how wide, and they guessed wrong. The picture that came out was stretched and distorted, showing a jagged, broken landscape of sharp peaks, like a field of shattered rock. It was wrong, but it was real. And on the 4th of February, it went out to newspapers around the world, a photograph from the surface of the moon, released not by the country that took it, but by a radio observatory in England. Now think about what that did to Moscow. Because the Soviet Union had not released anything. Not yet. Their own scientists had the real signal, the real images, the correct proportions, and they were tangled up in their own machinery, chained, as one account puts it, by secrecy and bureaucracy. The official Soviet news agency was doling out careful updates. A communications session here, a telemetry check there, the temperatures and voltages all within acceptable limits, the imagery promised, in the near future. Always in the near future. And while Moscow was being careful, an English observatory and a London tabloid had already shown the world what the moon looked like. The Soviet scientists were able to publish their own properly formatted images only a day later, on the 5th of February, and they did it alongside open consternation toward their enterprising colleagues abroad. Their greatest triumph, the first photograph from the surface of another world, had been scooped out from under them by the very openness of their own signal. It took until the 10th of February, a full week after the landing for the Soviet Union to hold its proud, triumphant press conference, chaired by the head of its Academy of Sciences, a man named Mstislav Keldysh, presenting the results of the mission to the world. By then, of course, the world had already seen the moon. Twice, once wrong, from England, once right, a day late, from Moscow. The secret had been kept for days and lost in hours. Now, let's slow down and look at what it actually took to put that camera on the moon in the first place. Because the landing itself was a small miracle of engineering, and almost nobody remembers how it worked. The probe was called Lunar 9. The whole spacecraft, fuel and frame and instruments together weighed a little over 1,500 kilograms and stood about 2.5 meters tall, roughly the height of a tall room. But that whole machine was really just a delivery system for one small, precious passenger. Tucked inside was the lander itself, a sealed metal sphere, a little under 60 centimeters across, about the size of a beach ball. Inside that ball were the radio, the timer, the heating system, the power supply, and a single television camera. That sphere weighed about 100 kilograms. Everything else existed only to set it down gently. The journey began on the 31st of January, 1966, from a launch site in the Kazakh Republic of the Soviet Union. The rocket's lower stages first lifted the probe into a parking orbit around the Earth, a low loop, just a couple of 100 kilometers up. Then an upper stage fired again, stretching that orbit out enormously and flinging Lunar 9 off toward the moon. To keep the spacecraft from overheating on one side during the long cruise, it set itself slowly spinning, using small jets of nitrogen gas turning gently in the dark, like a roast on a spit, so that no single face stared at the sun for too long. But here's a detail that matters more than it seems. The first measurements of that path, taken overnight, showed a problem. Lunar 9 wasn't actually heading for the moon. On its current course, it would sail right past missing by something like 10,000 kilometers. So on the 1st of February, with the spacecraft already most of the way there, roughly a couple of 100,000 kilometers from home ground controllers commanded a single, brief engine burn. A correction lasting under a minute, changing the probe's speed by only a few dozen meters a second. That tiny nudge turned a clean miss into a direct hit and put Lunar 9 on a collision course with the surface. I want you to hold on to that idea, that the exact path of this spacecraft was something humans were steering by hand, from very far away, with the tools of 1966. Because tracking a vehicle across that distance, in that era, was closer to an art than a measurement. Keep that in the back of your mind. As Lunar 9 approached, it turned itself tail down toward the moon, using the directions of the sun and the Earth to find its bearings. Then the descent began. At an altitude of about 75 kilometers, the probe shed its side modules, inflated a pair of protective airbags around the lander, and fired its braking rocket to kill its enormous speed. The main engine slowed it almost to a stop. Then, in the final stretch, smaller outrigger engines took over for the last gentle push downward. And the cleverest part was the very end. A long sensor stuck out below the spacecraft like a feeler. The instant that feeler touched the ground about 5 meters up, it triggered everything at once. The engines cut off, and the little sealed sphere, wrapped in its inflated airbag, was flung free. It hit the surface at the pace of someone jogging around 6 meters a second, cushioned inside its bag. And then it did something almost charming. It bounced several times across the surface of the moon like a thrown ball before finally rolling to a stop. And the choreography that followed was just as carefully timed. A few minutes after the lander came to rest, the inflatable bag that had cushioned it was cast off, no longer needed. Then the sphere unfolded, its petals swinging open, its antennas unrolling, readying itself to look and to speak. Every step of it had been planned on the ground and trusted to a timer, executed by a small machine entirely alone 250,000 miles from the nearest human hand. It came to rest on the western edge of the moon's near side, in a vast, dark plain called the Ocean of Storms, out near two craters named Reiner and Marius. The moment of touchdown, the 3rd of February, 1966. And here is where the great fear of the era met reality. Did the sphere sink into a bottomless ocean of dust? Did it vanish into quicksand the way Thomas Gold had warned? It did not. The ground held. The moon's surface, for all the theories, was solid enough to carry a lander. In a single bounce, Lunar 9 had answered a question that scientists had argued about for years. And that answer would matter enormously later, because it told the planners of the Apollo program something they desperately needed to know, that it was safe to send human beings down to stand on that ground. About 250 seconds after landing, 4 curved petals that had covered the top of the sphere swung open like a flower, steadying the lander and freeing the camera. Then it waited. It did not start taking pictures immediately. It waited for the sun to climb a few degrees above the horizon, so there would be enough light and enough shadow to see the texture of the world around it. And then, finally, it looked. What it saw was a flat, grey plain scattered with small rocks, stretching out to a horizon a little over 1 kilometer away. It built that view up slowly, line by line, sweeping a full circle around itself. In the areas closest to the camera, the detail was astonishing, for its time fine enough to make out features just 1 millimeter or 2 across, individual grains and pebbles in the lunar soil, and by photographing the same patches of ground at different times as the sun shifted, the scientists could read the lengthening and shrinking shadows to work out the true shape and size of the rocks and craters around the lander. The probe sent back 9 images in all, several of them stitched into panoramas, across radio sessions that added up to about 8 hours of contact. Its single dedicated science instrument, a radiation detector, quietly measured the dose of radiation falling on the surface early, practical knowledge for anyone who might one day stand there in person. And then, over the next few days, the batteries ran down. The last contact came on the 6th of February. The first eye humanity ever opened on the surface of another world closed for good, sitting in the dust where it had bounced to a stop. Now, remember that distorted picture Jodrell Bank had pushed out to the world, the one with the stretched, jagged peaks? What happened next is one of the strangest and most human episodes in the history of science. Because the world's experts looked at that wrong image, and almost every one of them saw exactly what they had always wanted to see. Thomas Gold, the man who believed the moon was a dust bowl, looked at the photograph and announced that it proved him right. The rocks scattered across the surface? Those weren't rocks, he said. They were clumps of fine dust. And the lander itself, he claimed, was already slowly sinking into the powder, and would soon disappear from view entirely, just as his theory predicted. Another astronomer, Gerard Kuiper, looked at the same picture and saw the opposite, a surface of bare, dust-free bedrock. A geologist from the United States Geological Survey, Hal Masersky, looked at it and saw a rough, sharp lava flow, clear evidence to him that the moon was volcanic. And then a reporter, chasing the story, asked him a question. Volcanic rock, isn't that where you find gold on Earth? Masersky, distracted, gave a vague nod. And the next day, the headline ran around the world. Lunar 9 had discovered veins of gold on the moon. Every one of these brilliant people was reading the future of an entire world out of a single stretched, misproportioned photograph. And they were all wrong. Because then the Soviets, finally, released their own version of the image, correctly proportioned this time. And the real moon appeared. Not a dust bowl, not bare bedrock, not jagged lava, and certainly not gold. Just a soft, undulating plain of fine grey dust, dimpled with countless tiny craters, with the occasional ordinary rock lying about. A quiet, unremarkable, solid surface. The disappointment in the press was real. There was no gold. But there was something more valuable, if you cared about how science actually works. A near-perfect demonstration of how easily even the finest minds will bend new evidence to fit what they already believe. And notice what made it possible. Not stupidity, not bad faith, just a single small error, one wrong guess about the shape of an image made under pressure in the rush to be first. From that one distortion grew dust bowls and bedrock and lava and gold, each expert reaching past the picture to grab the answer they had been carrying around for years. It's a humbling little parable, and it sits right at the center of this whole story. The first data from another world arrived stretched out of shape, and the world read its own reflection in it. Now, while this circus was playing out in public, a second, hidden version of the same race was unfolding in the United States, and it followed almost the exact same pattern. So, I'll tell you the first part fully, and then just the one detail that makes the second part worth knowing. American intelligence had been listening to Lunar 9 from the moment it launched. At the National Security Agency, analysts picked up the same shift the British had, the routine telemetry suddenly joined by a new kind of signal that they, too, recognized as a photo transmission. And just like Jodrell Bank, they scrambled to turn it into a picture. The pressure was enormous. One officer reportedly said the entire White House and Congress were waiting and they had nothing to show. It came down to a young electrical engineer named John O'Hara, who jury-rigged a solution out of his own hardware and borrowed recording equipment. His first attempt produced pure gibberish. He had to analyze the signal, realize its frequency was wrong for his machine, and build another piece of electronics to fix it. His second attempt produced an image distorted, again with the wrong proportions, the same mistake the British had made. And here's the one new detail worth keeping. When the Americans cleaned up their picture, they thought they could see a foot of the lander itself in the frame, close enough to make out Russian letters and numbers stamped on the metal. For a tense moment, they wondered if it was a message, a taunt left for them to find. It turned out to be nothing of the sort, just meaningless serial numbers. By the morning of the 5th of February, O'Hara had it working properly, and that same afternoon, the photographs from the surface of the moon were reportedly sitting on the desk of the President of the United States. There's a quiet irony buried in this. The agency's own security officers later tried to bring charges against O'Hara for going around the rules to get the right equipment. The charges were dropped. The man who helped put the moon on the president's desk was very nearly punished for it. And it's worth asking why a photograph from the moon mattered so much to people whose job was national security, not science. The answer is that the American intelligence community did not see Lunar 9 as a charming little science probe. They saw it as a warning. A soft landing, made gently enough to survive, was exactly the kind of step you would take if you were preparing to land something much heavier, next a crewed spacecraft, perhaps, or to build something permanent up there. The Soviet Union had already beaten the United States to the first satellite and the first human in orbit, and there was a real, gnawing fear that they might reach the moon's surface with a cosmonaut first, too. So those grainy Soviet pictures, printed on borrowed machines and rushed to the White House, did something concrete. They helped push the United States to press harder on its own program, the one that would eventually carry astronauts to that same grey dust. And there's one more anomaly, the only one that both sides noticed independently, and it's a gentle, eerie thing. When Soviet and American analysts compared photographs of the same patch of ground taken hours apart, the shadows had moved as the sun crawled across the lunar sky. That was expected. But something else had changed too. The lander appeared to have shifted slightly from where it started. The little sphere had, very quietly, settled into the soil beneath it. The moon, in its own slow way, had moved the first machine we ever sent to live on it. Here's a question that should be easy to answer, and isn't. If Lunar 9 is still sitting out there in the ocean of storms, petals open, camera dead, exactly where it bounced to a stop in 1966, then where, precisely, is it? We have an extraordinary machine in orbit around the Moon right now to answer exactly this kind of question. Since 2009, NASA's Lunar Reconnaissance Orbiter has been photographing the lunar surface in staggering detail, sharp enough to resolve features just a few feet across. It has found Apollo landing stages. It has found the tracks left by astronauts and rovers. It has found other lunar landers and the scars of old crashes. Over the years, it has built up an archive of more than 2 million images. So why is Lunar 9 a thing we know is there, in a region we roughly know still missing? Because of how small it is. The principal investigator of that orbiter's camera, the geologist Mark Robinson, put it plainly. Lunar 9 is a very, very small vehicle. Its core is that sphere, about 2 feet across. Even the sharpest camera ever flown around the Moon is operating right at the edge of being able to see it. As Robinson described it, you can stare at an image, and maybe that's it. But you can't really know for sure. Think about the scale of the problem. 2 million images, a target the size of a beach ball, somewhere inside a search area many kilometers wide, possibly sitting in shadow, possibly blending into a grey landscape full of rocks and craters that look just like it. Searching that by eye, image by image, is the work of a lifetime, and it might still come up empty. This is where the story leaves the past behind and arrives in the present. Because in the last year, 2 completely different teams attacked that exact problem, in 2 completely different ways, and both believe they have found it. The first team built a machine to do the looking. A group of researchers, led by a scientist named Louis Pinault, trained an artificial intelligence to recognize human-made objects on the Moon. They called it YOLO-ETA, and what's striking is how little they fed it. They taught it on just over 100 hand-labeled images of the Apollo landing sites, places where we already know exactly what spacecraft hardware looks like from orbit, the particular shapes, the sharp straight edges, the long shadows, the disturbed ground. The whole model was built to be light. Lightweight enough, in fact, that the people who made it imagined versions of it one day riding along on orbiters and landers, scanning the surface in real time on the kind of small computer you could fit on a modest spacecraft. Then they tested whether it had actually learned anything or just memorized. They pointed it at the Lunar 16 lander, a different kind of Soviet spacecraft it had never been trained on, and it found it with confidence as high as the high 70s. They pointed it at an Apollo site under unfamiliar lighting, and it picked out the lander with confidence into the 80s. They even aimed it at Surveyor 7, sitting in a difficult field of boulders, and it found that too. The machine wasn't recognizing specific spacecraft. It was recognizing the fingerprint of anything artificial against the natural gray of the Moon. So they turned it loose on a 5-kilometer-wide square around Lunar 9's rough, uncertain location. At first, it correctly threw out the obvious traps, bright fresh craters that a human eye might mistake for metal. But spreading its search across more and more images, it kept finding the same cluster of objects, one main feature, a few smaller ones scattered within a couple of 100 meters of it again and again, under different lighting, from different camera angles, at confidence levels that climbed into the 70s. That repetition matters. A trick of light shifts when the sun moves. A real object stays put. This one stayed put. And here's the detail that makes the cluster feel almost like a frozen photograph of the landing itself. Remember that Lunar 9 shed its side modules on the way down. The team noticed 2 small, very dark patches in the dust, just a few dozen meters away, the kind of ejecta you'd expect from small impacts, matching craters only 5 and 7 meters across. Their best guess is that those are exactly where the discarded side compartments came down. Heavy pieces falling in free flight, slamming into the surface hard enough to shatter and to darken the soil where they hit. If that's right, then the AI hadn't just found the lander, it had found the scattered wreckage of the entire descent, lying right where physics says it should be. There was also the matter of the horizon. The candidate site sits on ground, raised gently above the surrounding plain by something like 25 meters. For a camera perched a meter or so above that rise, the visible horizon would stretch out for nearly 10 kilometers, far enough that any distant hills would drop below the line of sight entirely. And that fits a strange feature of Lunar 9's real panoramas. They show a flat, empty skyline, with no hills breaking the horizon at all. The land matched the photograph. The second team did it the old way with human eyes. A Russian-born science communicator named Vitaly Egorov spent years hunting for Lunar 9 and eventually turned it into a crowd effort, live streaming orbital data so that ordinary viewers could help comb through the pixels. He pored over Lunar 9's own panoramas, studying the exact shape of the hills and the horizon, and tried to match that view to the landscape seen from above. One day, he later said, the landscape simply looked familiar. He felt as though he had looked around and recognized the very place Lunar 9 had been standing. Two methods: a neural network and a human being staring at pictures until one of them clicked. Both pointed to the ocean of storms. Both believe they have found humanity's first soft landing on another world. There is just one problem. They don't agree on where it is. And there's a deeper reason the man behind the machine cares so much, one that has very little to do with old Soviet hardware. For Pinault, finding Lunar 9 was really a first test of a much larger ambition. His real interest is in learning to spot artifacts that don't belong: debris, objects, traces of technology, not just our own, scattered across the moon, but potentially someone else's, somewhere in the solar system. He's affiliated with the institute that searches for signs of intelligence beyond Earth, and he's been open about it. This is a bit of an obsession. The logic is quietly stunning. The moon has sat almost unchanged for billions of years, gathering whatever drifts in from space and holding onto it. If you build a tool sharp enough to find a beach ball-sized lander we ourselves left behind, you have also built a tool that could, in principle, find something we didn't. The hunt for our own first footprint is practice for a much stranger search. The two sites don't match each other, and as one space journalist who covered both put it very simply, one of them is wrong, maybe both of them are. This is the part of the story that stays with you. We are talking about the single most famous robotic landing of the early space age. A machine that ended a great scientific argument, that proved the moon was solid, that quietly made the Apollo landings possible. And 60 years later, we cannot say for certain which patch of grey dust it is resting on. Remember that detail I asked you to hold on to that? Steering a spacecraft across that distance in 1966 was closer to an art than a measurement. This is where it pays off. The coordinates the Soviets announced after the landing were never precise to begin with. They were a best effort with the tools of the time, and when modern searchers went looking near those numbers, they found nothing. One of the candidate sites now proposed sits something like 25 kilometers away from the spot the Soviet Union officially claimed. 25 kilometers on a target the size of a beach ball. The triumph was real. The address was wrong from the very first day, and nobody noticed for half a century. There's even a second clue out there in that same region. The cruise stage, the part of the spacecraft that split away at the final moment of landing, may have been spotted too, resting a few hundred meters off from the lander itself, roughly where it should have come down once its engines fell silent. Two pieces of one machine, separated in the last seconds of flight in 1966, possibly sitting in the dust within sight of each other ever since. The experts who have spent their careers tracking down lost spacecraft are careful about it, and their caution is its own kind of lesson. Philip Stuck, who advised both teams, points out that Lunar 9 broke into several pieces as it landed, and that a true landing site should show all of them, and usually a bright scar where the engines blew the dust away. He isn't convinced either candidate clearly shows those things. Jeffrey Plessier leans slightly toward the human-found site because its horizon matches the old panoramas so well, but even he admits he doesn't know how you would ever prove it without sharper pictures. And that's the honest answer. To settle this, we need to look closer. There is talk of pointing a higher resolution camera on an Indian orbiter at one of the candidate sites, a spacecraft that has been circling the moon since 2019, with eyes a little sharper than the orbiter that found the candidates in the first place. There may be other spacecraft, in time, including new commercial ones that can finally resolve a beach ball-sized sphere from orbit and end the argument for good. For now, the question is simply open. The closer look has been asked for, and the answer hasn't come back. We are still waiting to find out where we landed. And Lunar 9 is not even alone in being lost. Its near twin, a later lander called Lunar 13, is missing too. So are old components from the early American probes. The truth is that the opening years of the moon race left a quiet scattering of machines across that surface crashed, landed, fallen silent, whose exact resting places simply slipped out of human memory. We were moving so fast and measuring so roughly that we lost track of our own footprints almost as soon as we made them. The people who hunt for these things now talk about it the way archaeologists talk about a buried city. Out there, certainly. Waiting, it's only a matter of putting a good enough camera in the right place. There's one last image I can't get out of my head. The man who searched for years by eye, Vitaly Egorov, did much of that searching after he had left his own country. He had moved abroad after opposing a war, and for him, the hunt for an old Soviet probe became something larger than national pride. He said he hoped his work might encourage even one person to look up at the moon and the stars, and to admire not only their beauty, but our strange, stubborn ability to reach them at all. That's really what this whole story is. Not gold on the moon, not a secret message in Russian letters, not even who scooped whom in the winter of 1966. It's that we built a machine the size of a beach ball, and we threw it across 250,000 miles of empty space, and we set it down so gently that it bounced and then opened like a flower and looked around at a world no one had ever seen. We were so eager to know what was out there that we could not even agree on what we were seeing. And then, slowly, over 60 years, we lost track of exactly where the thing was standing when it opened its single eye. We sent the first messenger to the surface of another world. The whole world fought over its first words. And now we are searching the dust with our smartest machines, just trying to remember where it sat down and quietly hoping it's still there, waiting to be found.